Today's lecture is about orbital velocity. Orbital velocity. This means that orbit always moves without standing or stopping. These are orbits. So around the Earth there are lots of orbits with different velocities. Their velocities depend on the distance from them to the Earth's center. So they have different velocities. These are called orbital velocities. If rocket A, B, and C that travel in uniform circular motion around the Earth are in different orbits, A, B, C, different rockets on different orbits, they have different velocities because they have different distances. If a rocket was launched to this point and this rocket travels along the circumference to this point, and this distance is p, and angle also changed from this, and let r be the radius. The orbital velocity is dp on dt. This is orbital velocity. Orbital velocity. And angle theta also changed. Therefore, d theta on dt, rate of change of angle theta. This is called the angular velocity. Angular velocity. Let omega be angular velocity. P equals r theta. Therefore, velocity is dp on dt equal d on dt times p equals d on dt r theta. Therefore, orbital velocity is d theta on dt times r. This is omega. Therefore, omega r. Orbital velocity is r omega, equation 1. Let's find the acceleration. This is horizontal distance, and radius r, angle theta, and vertical distance. Vertical distance is y equal r sine theta. Horizontal distance is x equal r cos theta. And let's find its derivative with respect to time t. And dy on dt equals r cos theta times d theta on dt. Sin theta was changed into cos theta. And this is omega, therefore r omega cos theta. And find its acceleration, vertical acceleration, d2y on dt2 equals, this will be changed, minus sin theta, minus r omega sin theta times chain을 d theta on dt. This is omega. Therefore, minus r omega squared sine theta. This is the vertical acceleration is minus r omega squared sine theta. And find the horizontal acceleration, the horizontal distance, the velocity. Hang on. So x equal r cos theta, and dx on velocity dt equal minus r sine theta times d theta on dt. This is omega, therefore minus r omega sine theta. The second derivative, horizontal acceleration, d2x on dt2 equals and minus r omega, this will be changed into cos theta, times d theta on dt. This is omega. Therefore, minus r omega squared cos theta. This is horizontal acceleration. Therefore, we can get total acceleration squared equals ay vertical acceleration and horizontal acceleration by Pythagoras theorem. And substitute a squared equals ay. Where is ay? Minus r omega squared sine theta squared plus horizontal acceleration minus r omega squared cos theta squared. Therefore, r squared omega 4 to the power 4 sine squared theta plus r squared omega to the power 4 cos squared theta. Common factor r squared r omega to the power 4 out. R squared omega to the power 4 sine squared theta plus cos squared theta. This is 1. Therefore, r squared omega to the power 4. A squared equals r squared omega to the power 4. A equals r omega squared. Yeah. A equals r omega squared. Equation 2. Equation 1 was v equal orbital velocities omega r. We can eliminate the omega equals v on r. Therefore, substitute this one into this. A equals r and v on r squared. Therefore, v squared on r. This is acceleration. Therefore, F equals ma is the same as m times v squared on r. This is equation 3. Let's recall Newton's force, universal gravitation times m on r squared. And this is the same. Therefore, g m on r squared equals m v squared on r. Cancel and cancel. Therefore, g m on r equals v squared. Therefore, we have got orbital velocity equal root g m on r. Yes,